But recycling is only one ingredient. To make a modern super tire, we start here. With raw,
we add the secret strengthener, carbon black. This fine powder is what gives the tire its color and its incredible resistance to wear.
Everything goes into the belly of the beast, the Banbury Mixer. Think of it as a giant, high-pressure kitchen mixer. Inside, massive rotors grind the materials together with thousands of pounds of torque, generating intense heat until when the chemistry is perfect, the machine spits out a steaming, hot batch of master batch rubber.
The hot rubber is immediately fed into the rolling mills. Giant steel cylinders squeeze it into a long, continuous sheet, removing air bubbles. This hot sheet travels through the festoon, a massive cooling rack where the rubber hangs like curtains, dropping to room temperature so it doesn't cure too early. Now, we shape the skin. The rubber is forced through an extruder, pushing it out in a precise, thick profile. This
automated markers spray a color code onto the rubber. This tells the builders exactly which type of tire this tread belongs to.
Finally, a heated guillotine slices the continuous strip into precise lengths. Each piece is weighed to the gram. If it's too light,
a tire is more than just rubber. Its true strength comes from its skeleton. Hundreds of thin, high-grade.
They enter the Calendar, a massive, precision rolling press. This machine's job is to sandwich the steel or
Under immense pressure, the hot rubber is forced deep into the weave of the fabric, or around every single steel wire.
Lasers scan the thickness 1,000 times a second. If the coating is off by even the width of a human hair, the entire roll is scrapped. To create the body plies, the fabric sheets must be cut on a diagonal bias. This angle is what gives
The steel sheets are chopped into much stiffer, narrower strips. These become the belts that sit under the tread to stop punctures. Meanwhile, we create the anchor, the bead. Thick steel wire is wound into a dense, unbreakable hoop.
This metal hoop is then wrapped in its own rubber coating. This ring is what will eventually lock the finished tire onto the wheel rim with an airtight seal.
Finally, we prepare the inner liner. This impermeable layer is the modern replacement for an inner tube, designed to hold the air inside the tire.
All the ingredients are ready. The tread, the plies, the belts, and the beads are gathered into a kit. It's time to build.
now we enter the assembly phase. The tire building machine is where flat layers meet physics.
First, the inner liner is wrapped around the inner drum. This airtight seal is the foundation of the entire tire.
Next come the body plies. This fabric layer gives the tire its flexible strength. The builder carefully splices the end.
Then, the steel beads are locked into position. These anchor points define the rim diameter and hold the entire structure together under pressure.
In a split second, the machine performs the turn-up. Side bladders inflate, wrapping the fabric body plies up and around the steel beads, locking them inside.
The barrel is moved to the shaping drum. Here, it is inflated with air while the sides compress. For the first time, it begins to look like a tire. Finally, the thick tread slab is wrapped over the belts. A laser guide ensures it is perfectly centered. If it's crooked, the tire will vibrate later. Mechanical rollers, known as stitchers, press down with immense force. They massage the layers together, driving out.
The result is a green tire. It looks like a tire, but it has no tread pattern and feels soft and tacky.
Before the fire, a layer of protection. The inside of the tacky green tire is sprayed with a special release lubricant to ensure it doesn't stick to the machine during the cook.
The tires travel to the curing row, the hottest part of the factory. These massive presses act as both a mold and a pressure cooker.
The tire is dropped into the mold. Notice the steel walls. The tread pattern is carved into them in reverse. This is where the tire gets its fingerprints.
Inside, a heavy rubber balloon called a bladder inflates with high-pressure steam. It forces the soft green tire. The press slams shut, locking with tons of hydraulic force. The tire is now trapped between the expanding bladder. Now, science takes over. For 15 to 25 minutes, superheated steam triggers vulcanization. When the timer hits 0, the press opens. Through a cloud of escaping steam, the tire emerges.
You might see tiny rubber hairs on a new tire. These are vent spews. They are formed when trapped air escaped through tiny vent.
But the rubber is still hot and remembers its shape. To prevent warping, it is immediately inflated on a cooling rack, locking it.
Cooled and cured, the tires begin their journey to the final exam. They look perfect, but in this factory, first, a quick shave. Rotating blades trim off those tiny rubber vent spews to ensure a smooth, clean finish for the showroom.
Despite the robotics, the human eye is irreplaceable. Inspectors rotate every tire under bright lights, hunting for even the smallest surface blemishes.
They don't just look, they feel. A gloved hand runs over the bead and sidewall, checking for microscopic bumps or air pockets that a camera might miss.
Next, the dynamic balance test. The tire is spun at highway speeds. Sensors measure wobble.
The uniformity machine presses a steel road wheel against the spinning tire. It measures force variation.
But the most critical test is invisible. The tire enters the X-ray chamber. We need to see through the opaque rubber to the steel bones inside.
On the monitor, the skeleton is revealed. The operator verifies that the steel belts are perfectly centered and the wires are straight.
If a wire is crossed or a belt is off by a millimeter, the system marks it defective. These tires are slashed immediately. In this factory, there are no seconds.
Passing tires get a stamp of approval. Automatic guns spray those yellow or red dots you see in the store, technical indicators of the tire's heavy point for the mechanic. Finally, the tires are scanned and sorted. Giant robotic gantries stack them into towers based on size, destined for warehouses around the globe.
For colder climates, the process adds one more step. These are winter tires, engineered with a softer compound to stay winter.
To grip the ice, we add claws. A high-speed robotic gun inserts tungsten carbide studs into precise holes.
But machines can only measure so much. To prove they are roadworthy, the tires leave the factory and head to...
First, the hydroplane test. Cameras beneath a glass track watch how the tread channels water. At 60 miles an hour.
Then, the lateral grip. Drivers push the tires to the breaking point in the slalom. We are watching the sidewall stiffeners.
Silence is science. In an anechoic chamber, sensitive microphones list singing of the tread.
Training. Endurance is tested on the road wheel. This tire will run at maximum speed under heavy load for days, simulating.
We need to know the breaking point. The plunger test forces a steel spike into the inflated tire to measure exactly how much force.
In the Sub-Zero facility, winter tires fight against pure ice. Data loggers inside the wheel measure the micro-friction of the specialized rubber compound.
After the abuse, engineers analyze the heat signature. A good tire spreads the heat evenly. Hot spots mean failure points, and failure is not an option.
The approved tires enter the cathedral of rubber. In this distribution hub, millions of units wait in silence.
When an order comes in, humans don't climb ladders. Automated pickers race up the racks, retrieving specific sets for dealerships and depots with zero errors.
At the dock, loaders use a technique called lacing. They weave the tires together in a locking pattern, packing. The journey ends at your local shop. The stiff, new rubber fights back, but the mounting machine forces the bead over the rim, marrying the tire to the wheel.
Then, the inflation. We listen for the pop. That distinct sound is the steel bead snapping into its seat.
But manufacturing isn't perfect. A final balance check is required. Small weights are added to the rim to counteract.
Now, the work begins. This patch of rubber, the size of a human hand, is the only thing connecting your 2-ton vehicle to the earth. For the next 40,000 miles, it will endure baking heat, freezing cold, and punishing potholes.
But nothing lasts forever. Deep in the grooves, the wear bar emerges. When the tread is flush with this indicator,
The grip is gone. The tire is removed, replaced by a new one. But for the old casing, this isn't the end.
to separate the complex materials, we go sub-zero. Liquid nitrogen freezes the rubber to minus 300 degrees, making it brittle enough to shatter like glass. The dust enters the pyrolysis reactor. This isn't burning, it is thermal decomposition. We bake the rubber.
Without oxygen, the tire cannot burn. Instead, the heat breaks the chemical bonds. The solid rubber vaporizes, turning back.
This vapor is captured and cooled in condensers. As the temperature drops, the gas turns back into a liquid, creating tire pyrolysis oil.
Sir, it is indistinguishable from crude oil. This liquid gold can be refined into diesel fuel or used as a raw ingredient.
The gases that don't turn into oil become syngas. We don't waste them. They are piped directly into generators to...
What remains is the skeleton, recovered carbon black. This is the valuable reinforcing powder we added in step 1, now liberated from the rubber.
This recovered carbon is refined and pelletized. It is no longer waste. It is a premium raw material, ready to be sold back to the rubber industry.
The loop is closed. This recycled carbon is mixed with fresh rubber to create a green tire compound, indistinguishable in quality from the original.
This is the future of manufacturing. A tire that is born from the road, serves its purpose, and is reborn. But the evolution hasn't stopped. We are approaching the era of the non-pneumatic tire.
Punctures become a thing of the past. These structures can drive over spikes, glass, or jagged rocks, deforming to absorb the impact and instantly snapping back to shape.
Imagine never buying a new tire, just reloading it. 3D printing technology is testing ways to print
Tires are getting a brain. Tiny sensors embedded deep in the rubber constantly talk to your car's computer, measuring temperature.
Designers are even breaking the wheel itself. Spherical tire concepts use magnetic levitation, allowing...
Sustainability is driving biology. We are moving away from oil. Scientists are now harvesting latex from the roots of specialized...
New living compounds are being tested that can heal themselves. When cut, the molecular bonds naturally attract and seal the wound, fixing a puncture while you drive.
Adaptive treads are on the horizon. Tires that physically morph their shape, opening wider channels when it rains and smoothing out for speed on dry highways.
This technology often starts here, on the track. Racing tires are the laboratories of speed, where data gathered at 200 miles an hour.
It is easy to forget what lies beneath. Hidden inside this black donut is a complex architecture.
But machines don't have a pulse. The soul of the tire comes from the hands that build it, the watchful eyes that inspect it. We trust them with our most precious cargo. When you hit the brakes or turn the wheel in a storm,
They are the only contact between us and the elements. Through blistering heat, crushing ice, and torrential rain.
They give us freedom, the ability to conquer distance, to explore the unknown, and to return home safely.
They are often ignored, kicked, and covered in road grime. But they are the unsung heroes of every journey.
Back in the factory, the press opens again. Another one is born. Another 20,000 miles of potential, ready to meet the road.
The fires here never go out. The mixers never stop turning.
From a rubber tree to a high-tech safety device, that is the incredible journey of a modern tire. If you enjoyed this ride, don't forget to hit that like button.
Subscribe for more deep dives into the world's most fascinating mega factories. I'll see you in the next one. Drive safe.